All right, in the last lesson, we talked about how we have these formulas, the sum and difference formulas for cosine, sine, and tangent, that help us figure out cosine, sine, tangent values for angles that aren't on the unit circle, but that we also don't have Pythagorean or triangle information for. So what we can do is take an angle and break it up into two other angles that are on the unit circle. We can add those two angles together or subtract, and then whichever one we do, whether we're looking for cosine, sine, or tangent, we then use these formulas to calculate that value. So that was the last lesson. So in this lesson, we are going to be doing problems where we're given trig ratios and then use those in the formulas instead of angles. Now, this first problem up here is just a kind of like a little warm-up problem before we get to all of these down here are related to each other, these three. But this one is just by itself. So what's happening in this first one is we're being asked to find tangent of 7 pi over 4 minus theta when tangent theta equals 1/4. So if you notice, we have an angle here in radians and then just a variable for an angle here, theta. Now the basic idea is the same. This first one listed is my alpha. The second one is my beta. And so it might feel at first like we're not going to be able to calculate, but the rest of the problem tells me that tangent of theta, even though I don't know what it is, I know that its tangent value is 1/4. So I'm going to be using the tangent difference formula because this is being subtracted. So here's what that formula looks like. This is from yesterday. And 7 pi over 4 is going to go in everywhere I see an alpha. So 7 pi over 4 goes here and here. And then a theta is going to go in everywhere I see a beta. So I'm going to put theta in here, and then I'll show you what to do after that. All right, so now we're here. So for the 7 pi over 4s, we can go to our unit circle and read off the tangent value, which is -1. And then when we see tangent theta, because we don't know what theta is, but we do know that tangent theta is equal to 1/4. So we just are going to plug that in for the tangent theta. And then on the bottom, I have 1 plus tangent 7 pi over 4, which is -1, times tangent theta, which is 1/4. So in the numerator, we have -1 minus a fourth. So they're the same sign. So we add and keep the sign. So that's 1 1/4 or 5/4 negative. And then on the bottom, I have -1 times a fourth is negative. So this is really 1 minus a fourth, which is 3/4. Now that is a keep, change, flip situation, a fraction over a fraction. So keep the top fraction the same, change to multiply, flip the second fraction. And now that we're multiplying, we can cancel. The 4's cancel, leaving me -5/3 after I multiply across the top and bottom. Okay, this next section works a little bit differently. We're given some information, and we're using that information for all three of these problems. So you'll see that we have some information for an alpha, a beta, and then we're being asked to find tangent, sine, and cosine using our formulas. Now, if you're looking at the tangent formula, for example, you need tangents to do those formulas. For the sine formulas, you need a combination of sine and cosine, and same for the cosine, a combination. So for each angle, we're going to need all three trig function values, sine, cosine, tangent. But if you notice, we're only given sine for alpha and beta for and given cosine for beta. So before we can even do these problems, we need to figure out cosine and tangent for the alpha and sine and tangent for the beta. And if you recognize this from our previous units, that means we're going to have to do triangle math using Pythagorean theorem. And we're also given this restriction that the alpha and the beta are between 0 and pi over 2, meaning they're somewhere between 0 and 90 degrees. So they're in the first quadrant. So here's how we're going to get started with that. I'm going to come over here and just use this area to do my math. And I'll do alpha first. So for alpha, we're given that the sine is 3/5. And from our trig ratios, we remember that's our y and our r values. So if I already know my y and my r, the third thing I need that's missing is x. So remember we have, this is how our x, y, and r relate to each other. X squared plus y squared equals r squared. I know that y is 3 and r is 5, so I'm going to plug, and I'm missing x. So that's going to stay x. Y squared becomes 3 squared, r squared becomes 5 squared. So 3 squared is 9, 5 squared is 25. So that's going to give me x squared equals 16. Square root both sides gives me plus or minus 4, but because our angles are both in the first quadrant, we know that x has to be a positive 4. So now I have x is 4, y is 3, and r is 5 for alpha. So I can now write ratios for all of 3 trig functions. We already knew sine was 3/5. Cosine is x over r, so that's 4 over 5. And tan is y over x, so 3 over 4. And we're just going to have these hang out here. We're going to use these in a bit when we go to do our formulas. All right, so now we're going to do the same thing with our beta information. I'll do the same thing with our beta information. So for beta, we're given that cosine is equal to 8 over 17. That is x and r. So we set up our Pythagorean theorem, x squared plus y squared, which I don't know, equals r squared, which is 17. 17 squared is 289. 8 squared is 64, and I'm subtracting that from both sides. That gives me 225. The square root is 15. Needs to be positive again because our angles are in the first quadrant. So now let's set up our 3 ratios for beta. Sine is y over r, which is now I know is 15. R is 17. Cosine is x over r, which I already know that is 8 over 17. And tan is y over x, so 15 over 8. So now we have these values, and we can use our sum and difference formulas to calculate these problems. So looking at number 1, I have tan alpha plus beta. So that's the sum formula for tan. I'm going to plug in my tan values for alpha where I see tan alpha and my ratios for beta where I see tan beta. So tan of alpha is 3/4 plus tan beta is 15/8 over 1 minus tan alpha times tan beta. All right, in the numerator, we need to make like fractions with common denominators. They have a common denominator of 8, which means rewriting the first fraction by multiplying by 2 top and bottom. So this gives me 6 over 8 plus 15 over 8, which is 21 over 8. In the denominator, You have to, multiplication comes before subtraction. So multiplying this gives me 45 over 32. And then this 1 in front I can rewrite with a common denominator of 32. So 32 over 32 is the same as 1. So next, in the denominator, 32 minus 45 is negative 13 over 32. So now I have a keep, change, flip. Keep the top the same, change to multiply, flip the second fraction. Simplify anything that can. 32 over 8 simplifies to 4. 4 over 13 doesn't simplify. So 32 over 8 simplifies to 4. And then 21 over 13 can't simplify. 4 over 13 cannot. So we multiply across the top and the bottom. And that gives me negative 84 over 13. A mixed number would be 6 and 6/13 negative if you wanted that. Okay, so I want you to pause the video and try this cosine problem down here. Pause the video and then come back and try that. This is cosine alpha plus beta, so you're going to be using the sum formula and using your cosine values and your sine value ratios that we already figured out. Actually, try both of these, number 2 and number 3. Okay, this is a difference formula for sine, so hopefully you used this formula right here. Sine alpha cosine beta minus cosine alpha sine beta using the ratios that we found here. Here is my work for that problem number 2. 3/5 times 8 over 17 minus 4/5 times 15 over 17. Multiplication first, so multiply these two fractions together, then these two, so that's going to give you 24 over 85 minus 60 over 85. They have a common denominator, and that's negative 36 over 85. Number 3 was the sum formula for cosine. So that's here, cosine alpha times cosine beta minus sine alpha times sine beta using the ratios that we came up with earlier. So 4/5 times 8 over 17 minus 3/5 times 15 over 17. Multiply the numerators and the denominators. So you're doing the multiplications first individually and then subtracting after that. And you should have had negative 13 over 85.